Hello everyone, Brant here with TIS. We've been promising a video for you, and it's basically just to get a few questions out of the way as far as the basic operations of this transmission. What's so special about it? How does it operate in very fundamental terms, and what can be expected from it? So we've pulled out this older prototype that we've got, and we're going to do our demonstration through that. It's not in the best condition. It doesn't demonstrate the smoothest operation, but I think that the idea can be portrayed very well through this. We have, in this older prototype, we have what we believe to be the simplest and yet most capable CVT that we know to exist. There are no ring gears necessary, though in this prototype we did use one in the reference assembly, and I'll explain where that is in a moment. It's actually just right in this region right here. We don't actually use the ring gear in any of our three versions that we've got right now. The input and output range in these is extremely wide. We're talking about on the order of 1 to 0.1 to around 1 to 0.8 or even more. It really depends on how the whole thing is designed for any particular vehicle. It can be controlled with no source of power outside of the main power plant if desired. It's reliable, it's low maintenance concept, and it requires no changing of position between any of these components. They move around each other, but there's no shifting side to side of any component whatsoever. Whereas in most CVTs, you're going to have sort of some sort of conical setup where a belt is going to change position, and that can delay shifting and so forth. This is very automatic and continuous, and you'll see that, I think, here. The ratios are actually stepless and near instantaneous, so as a new gear is desired or demanded based on the parameters of operation, that particular gear ratio output can be immediately achieved. So the user is going to experience no noticeable lag in shifting, and the ratio can occur while under power without interruption. So that's an outstanding feature that we believe is unprecedented. From a higher level perspective here, we've got three versions available, or that we are working on and that we have described in our intellectual property. One operates on a CPU and a motor controlled version that continuously reads the wheel and crank outputs and responds appropriately. The second option is fully mechanical version, simply relies upon wheel speed or other mechanical determinants to choose where in the range of gear ratios it should be operating. And finally, there's a version that allows for full mechanical feedback, but can be overridden by computer control to adapt to more aggressive driving and riding conditions, and or allow more freedom of choice from the user. So anyway, in all three versions, the same modular unit is used, and we just multiply that unit and use it for different purposes, but essentially that is found right in this region. Here it's essentially, you could ignore these gears, you could ignore everything below here, and the primary functional unit is an input, a pass-through of planetaries, and an output gear, and then the output actually is the output to the vehicle, and it rides on bearings between all of these components here. And that's just essentially multiplied and used in various ways to achieve the desired outcome. It's important to note that the power unit is not there to add power to the vehicle. So in this model, we have this. This is a stepper motor, or not a stepper motor, a servo motor, and this is just to sort of demonstrate the feedback from the vehicle, but it can also be utilized as a servo or a stepper motor or a worm drive, driven by a computer control, and that's going to provide feedback. But the important note here is that this feedback doesn't actually power the vehicle in any way. It's actually a relief mechanism, and it allows to drop into a higher or lower gear based on how much we're relieving this piece right here, which is the input reference carrier. Okay, so now I'm just going to go through the basic rundown of the operation. It's important to note that with the primary crank located here and the final output here, as long as this reference carrier is held still, we have the maximum output ratio when we crank this. So you're going to see that there is quite a bit of RPM coming out of that. It goes all the way down through infinite increments to the lowest gear ratio, and that's if we're going to hold this still. We're going to see that there's more movement on the reference carrier, and like I said before, this is a really clunky model. We have much smoother operation now, but this is sort of the best demonstration model for the purposes of my talking here. As this reference is relieved, you're going to notice that there's absolutely much less RPM coming out at the end. And so when I do this, you're going to see much slower output there. And so everywhere in between maximum RPM output and the lowest, and I can't really control this right now the way that it's set up, showing different levels of output of the output wheel or the vehicle wheel and speed, but everywhere in between the maximum ratio and the lowest ratio, you have gears ready and available to you at all times. So that's the basic principle of operation. We definitely have more coming out for you. We just wanted to get this little explainer video or a couple of videos out so that the basic principles of operation are available for anybody interested in how this thing works and what it's going to bring to the table in the future. Thanks for joining, and we will be releasing more info in the near future.